Thank you, FedScoop, for hosting AI Week. My name is Andrew Fairbanks, and I'm the General Manager of Federal Services at IBM. And I'm really delighted to take part in the dialogue this week about artificial intelligence and the ways in which it can be harnessed to help solve government problems. It's been a pleasure watching other videos in this series, hearing about all the great work that's going on across the government. In today's session, I'd like to share with you three main themes. One is IBM's view of where we are at in the evolution of artificial intelligence, highlighting some tangible examples of government agencies and the work they're doing in this space. I'd then like to share with you our view of where we think the field is going, both in the short term over the next 3 to 5 years, and then longer term. And finally, I'd like to share with you an ethical framework that I hope we as a society can adopt as we confront the power of what technology is able to do, and that we put the right constraints on that as we move forward. So first, I'd like to just level set and make sure that we're all starting with a common definition of what artificial intelligence is. Put simply, artificial intelligence is capability of a piece of technology to receive a series of data inputs, to make sense of those inputs, and then to use that data to either drive towards a decision or to make an action, and to do that without direct human intervention. At IBM, we call this cognitive computing because the ways in which computer systems process that is very similar to the way the human brain works. IBM has been at the forefront of this field for more than 50 years. It started with the work we were doing to get the Saturn rockets back and forth to the moon, and has then gone through a number of different phases as we've worked through it. We think of three layers of artificial intelligence. Artificial intelligence is sort of what we began back in the 50s, which was really using computing systems to really perform large-scale computational tasks at a rate and speed and volume that the human brain simply wasn't able to accomplish. That's the kind of technology we used in getting the rockets back and forth to the moon. Machine learning then takes that a level deeper and creates a series of algorithms that continuously learn from real world experience and outcomes to constantly refine themselves and improve, to then drive those same kind of decision support and that same kind of triggered actions that we see in artificial intelligence. And deep learning then takes it to the very next level, which really gets up into the layer of functioning that's more akin to the brain. We're using neural networks and multiple senses, the ability for the computers to see visual data, to hear auditory data, to be pulling in data from all different layers stacked on top of each other to be able to make decisions and take complex actions. We also think about AI as being in sort of three major categories. Narrow AI sort of exists today. It includes deep learning. It tends to be focused on a single task that really drives either a volume of activity that's well beyond what people can perform, or with some degree of increased accuracy. One of my favorite examples in this space is work we're doing with the Transportation Security Administration, applying cognitive techniques and artificial intelligence to the scans that we do of luggage, for example, at the terminal. And data has shown that by helping and train computer systems to begin to recognize patterns of a gun, a knife, or other kinds of contraband, the system can actually perform that task at a much higher fidelity than even people focused on the task can do. The second area that we focus on, which is becoming more commonplace now, but we're on the cusp of a real explosion here, is what we call broad AI, which becomes more disruptive and pervasive. And this is where you can begin to use the neural networks that I mentioned earlier to perform multitask, multi-domain, multimodal kind of work, taking in sensor data, taking in data from all different kinds of areas to again enable an action to be taken. Some of the work the Department of Defense is doing around Project Maven, I think, is a great example of this, where you have IoT sensors all around the world that are being used to help improve the performance of drones and autonomous vehicles. That's sort of the current version of where we're at with AI. And then I think as we move forward, there's the chance for general AI, which I think if you think 2050 and beyond, and you start to envision sort of robots or complex machines that can actually interact with you in much the same way you might interact with a human to perform a function, where they can not only do just purely programmed tasks, but where they can begin to do those tasks autonomously, often very complex tasks. And perhaps they will even be able to begin using moral reasoning and other kinds of techniques as they move forward. That's where we see the world of AI and machine learning going at this point. But I think when we think forward 20 years, I'm sure we haven't even begun to imagine what will be possible. I like to think back 20 years and to think back to the mid 90s, before email became pervasive, before the cell phone became pervasive, before the internet really had really taken hold. Think about how much our world has changed over the last 20 years. And I don't think many of us at that time could have anticipated the world we live in today. I'm sure the pace of change is going to be very similar in this world of AI and machine learning as we move forward. As I mentioned, IBM has sort of been at this task for about 50 years. Again, we started with sort of some of the very narrow tasks. The 1958 slide or shot you see there really is from work we did with the space program, which was, again, creating the instrumentation that got those rockets back and forth to the moon. It's amazing to think back on that time, because if you think about that instrumentation unit, it actually had less memory than some Hallmark greeting cards have today. But they were able, through brute force and analog devices, to be able to perform some of those tasks. We then took on a series of grand challenges, really focused on increasingly complex games, which I think have represented different milestones in the development of artificial intelligence. We began with a computer program back in the early 90s to win the game of backgammon. We then graduated to chess. I think many of you may remember the Deep Blue back in the mid 90s, when ultimately the computer beat Garry Kasparov in a game of chess. And then we progressed into 2011, where we famously developed the Watson system that beat all of the grand champions in Jeopardy, and by a pretty convincing margin. Today, in 2019 and 20, we're focused on other challenges. So 2019, we focused on creating a system that could actually engage in conversation with people in a way that would sort of win the Turing test, and where a person engaging with that machine would not be able to tell whether they were actually engaging with a human or a computer. And this year we have a really exciting challenge, which we call the Mayflower Project, where we have a completely autonomous ship that is traversing the oceans around the world, doing all kinds of research without a single person engaged in that. It's a solar-powered, AI-powered machine that ends up doing all of that's powered by edge computing, by intelligent automation, live feeds to our weather company data, so that it can make informed choices about for upcoming weather, upcoming wind, how to avoid challenges, and can make all of those kinds of human choices that captains and crews often make in navigating a ship to actually perform a mission entirely autonomously. And to me, I think this picture sort of reflects kind of where we've come in the world of artificial intelligence. When you think back to 1997 in chess, we were really focused on challenges that had very well-defined set of rules, a finite set of possible moves, and one very clear outcome. And we were able to harness the power of technology to solve that challenge, sort of a classic computer problem. By the time we got to Jeopardy, it was a very different challenge, right? When you think about that game, you need systems that can understand nuance and idiom, plays on words, and have just a rich background in all of this cultural data to be able to draw out answers. And it had to be able to do that in very short time period in order to win the time battle against the competition. And it had to also be able to calculate sort of its certainty with an answer in terms of understanding whether or not it wanted to bid. So really a phenomenal challenge. And we won that, right? That's where AI started to mature within the past few years. And now we're taking on the challenge of these autonomous ships. And if you just think about all the complexity that goes along with doing that, we now have the capability with artificial intelligence to be able to do that. Exciting times. We're using multiple techniques in terms of how we do this, right? Systems are able to do language translation, we're able to do speech transcription, to drive natural language processing and the engagements. That's why this technology has become so popular in the world of customer service and help desks, because chatbots and agents are now able to respond to citizen questions in real time with an incredible level of accuracy, which allows agencies to perform the work much more efficiently. This is all done through being able to draw entities and relations between facts, patterns, using object detection, facial recognition, all these different kinds of techniques that are really enabling very complex processes to be done using these tools. Many examples within government that I think are exciting. And I think particularly in the areas of case management, in terms of predictive maintenance, any use case that really is manually intensive, paper-based, rules-based, is a great candidate for adoption of AI. I wanted to share a few examples with you of where this is really working well. The Veterans Administration is using this for its mail automation. It gets hundreds of thousands of packets of mail every day. And this creates a real bottleneck in terms of the processing of benefits and backlogs for people to receive the benefits they need. What we've been able to do is to automate that process so that we can digitize that information using optical character recognition, populate that into data elements that can be used to make decisions, and to use algorithms to actually process downstream information. It's saving hundreds of man years of work and significantly reducing the backlog on that key function. Social Security Administration is using this for a similar way in terms of benefits adjudication. And the Patent and Trademark Office is using it also to be able to help people filing for patents and for adjudicators in making their decisions. Again, AI is a great tool for anything that has a vast corpus of data that needs to be sorted through quickly to help drive a decision consistent with known rules. So in terms of the path to the broader AI, there's a few things that I think are really needed as a platform. The first is you need sort of explainable data. Again, a set of business rules, a corpus of data that you can use to be able to train a system to be able to answer questions. Security is also really important. As we move towards more mission critical systems, it's both important to protect the data that exists in these systems, but also when you think about the world of drones and autonomous vehicles, or the security of power plants and the power grid, you need to be able to secure that and protect it from hacks. And then ethics, which I'll get into a bit. You know, the more we go down this path, the more ethical situations we confront that we need to be mindful of. So we have created an ethical framework that we really think is important for government decisions, or for governments using AI to make sure we're protecting. You know, one of the areas that's come into focus this year is the whole area of facial recognition and some of the racial bias that exists in the technology today. You can also imagine, as we get more military autonomous vehicles, that, you know, decisions around whether to fire or not fire really end up becoming life and death in cases of global stability. So we're of the mind that we need an environment where this is decision support and not replacing humans, particularly in those areas where there really are ethical and moral concerns. And we believe that to optimize the power of AI while operating within those constraints requires data governance and privacy, an understanding of where there is human or moral agency required to make that a decision support model, and to provide transparency and explainability and accountability for all decisions. So as we move forward into the next 5 years, I think that's going to become even more important, right? As we get into the areas of, or the capability of robotics in the future, and of entities being able to perform these complex tasks, it's going to become really important that we end up governing these actions with that ethical framework as we move forward. You know, as we move forward, I think the changes that we ultimately see coming in the world around the corner are around unsupervised learning and federated learning. AI to date really has been around humans training models based on existing data that then allow downstream decisions to be made. Unsupervised learning is when the systems are actually able to draw these inferences from unstructured data themselves and to provide that context to others. And federated learning is flipping the model in terms of how things are typically done today, where data flows from outside systems into one system where decisions are made and then pushed out. The needs that we're seeing from agencies now are really making decisions out on the edge, pushing the algorithms and the capability out to those sensors and devices that are out in the world to allow that activity to occur there, rather than having to bring everything in and then push back out. These are going to open incredible possibilities, I think, for transforming how we work across all agencies. And I look forward to seeing what it becomes. Thank you again for your time today. If any of you are interested in talking more about AI and machine learning and the opportunities for transforming how your agency works, I'd love to have a conversation with you. Thanks again.